And I guess at this point I would turn this over to Burnie. Where's Burnie? Right there, program chair, and he can introduce tonight's speaker, if you would, please.
Thank you.
Yeah.
Hi, Burnie.
Hello, Tom. Those of you who saw Tom's exhibit at the show, I'm sure were very impressed, as I was, with the variety and the knowledge that he has in meteorites. So I thought it would be fun if we had a program that he would put on, and so
I will.
Here he is.
Thanks. Rich, if you want to maybe show me how to get this thing fired up on the little projector there. Looks like it's probably obvious, but
That'll take about 10 seconds.
cool. Ah. Well, I'm going to be talking about meteorites. I can tell you that without assistance. And I'm not a scientician, so this isn't a scientific paper. I'm not going to give you complete footnotes or bibliography, but everything I'm going to tell you is stuff that is as true as I can find to the best of my knowledge. I've been collecting meteorites for about 10 years. I've never found one. Everything I have in my collection I've purchased or been given as a gift. We cut off a little on the right side. Is that normal?
Yeah, that might be a...
I could just scrunch the window down, I bet. Bigulate it a little here. Oh, hey.
Let me...
Yeah, you want to do it? Yeah. Nice. Get this thing calibrated. My friend Steven Cerio is a comic book artist, and he redid the front cover page of his upcoming comic, which he won't even tell me the name of, but did a title slide for me. He said he had about 200 hours in the drawing. And I think over the course of about 2 weeks. And then he grayed out the middle and put some lettering on it for me. So if you like the artwork, look for Steven Cerio.
Yeah, I like that. Is that right?
Yeah, it's great.
Okay.
That's center.
The kick. And you want me to do the lights for you?
Sure, yeah. Get us down to a dull roar. Sweet. So, thanks, Rich. Some definition of terms. I made some handouts so that nobody has to memorize it all. If anybody wants to take one of these, they're single sheet, double-sided, up here for the taking. I arranged meteorites here in the round so everybody can gather around the table, and this is basically the same stuff that I brought to the show, but you maybe get a closer look at it when it's not behind 2 layers of glass. I got a couple of them out. This box here has some meteorites and some meteor wrongs, and see if you can tell the difference. The first thing to know about meteorites, really, is that they're named for the place that they fell, or that they're found. And the difference between a fall and a find is that a fall was seen to fall from the sky, and it's, there's a fireball, there's a meteor streaking through the sky. A meteor is the term for the fireball you see. A meteorite is the term for the object that you would find. So a find is both the name of a meteorite that you actually find, and then it's also a general term for meteorites from a particular locality. So like Brenham, Kansas, there's more than one stone in the Brenham Fall. And so, or no, I'm sorry, yeah, Fall is the name for the group. I guess I could actually look at my notes. Fall is the name for all the stones from a particular group. So moving right along, the basic types of meteorites are, you've got stones, which make up the largest percentage of them. Roughly 80 to 86% of observed falls are the stony type of meteorite. Well, actually higher than that, probably closer to 90% are stony. The stony irons are a combination of stone in an iron matrix, a nickel iron matrix, and those only represent 1 to 2% of falls. And then nickel iron represents about 4 to 6% of falls, but it represents about 2/3 of the meteorites that are found. And the reason for this is that the iron meteorites tend to resist weathering, so they last a lot longer, and you can find them with a metal detector. As opposed to the stony meteorites tend to look like rocks. And so you could look at a lot of rocks and not notice that one's different. So a lot of the historic meteorites are mostly all irons. The meteorites that are millions of years old are mostly all iron. And the iron is actually composed, whenever you find iron in nature, it's not pure, it's got nickel in it. And depending on how much nickel and how much iron, you've probably seen, let me see if I've got, let me just go through a couple examples to get to the slide that I want to show. This is a stony meteorite. This was a hail of pebbles in China in 1997, which fell a couple days before, I think, was it Deng? Chairman Deng died, and the hail of stones was considered to be an omen by a lot of people in China. Little black rocks, and you can see in this first one there's a. Anybody got a laser pointer? You can see there's an area that's chipped away, and this particular shot's not very well focused, but you can see the inside of the stone through the fusion crust. The fusion crust is a glassy crust that happens as a result of the atmospheric friction as the stones are falling. Here's some stones that fell in. It was Upper Volta at the time, I think. Now it's called Burkina Faso. These are stony meteorites, and these are pretty freshly picked. I think the Gao fell in roughly 1997, which I started collecting in like 98. So these were some of the first stones that I bought before the price had a chance to go up, which the price tends to depend on rarity and how much is known. This was a pretty big meteor shower, and a lot of the locals were in tune to the fact that they could actually sell these things to the people who came around offering money for them. So here's one from right upstairs. Rich was kind enough to let me and help me open up the meteorite case in the museum, and we got some nice photos with no glass in the way. So this is one from Texas. It's a black chondrite. A chondrite refers to there's little spheres inside of a lot of stony meteorites. Here's one that fell in Finland, and this is in my collection up here. That's got some of the biggest chondrites you're going to find. The chondrites are the little round spheres of like quartzy material, and what they represent is the pre-planetary matter that's floating around out in space, that before planets and stars form, there's just all this stuff and gases floating around, and because gravity depends on the mass of an object, once stuff starts clumping together, it starts to clump more stuff together. And the chondrites are considered, they're thought to be a pretty primitive form of celestial matter. So the stony meteorites are neat scientifically, because you can actually get a look at what material planets and stars form from. So there's the other side of the same rock. And I've included, there's a US dime in most of these photos for scale. So you can see that one, the stone, it's about 1.5 inches round. This is a stone, it's a stony meteorite from Western Australia, I think. Great town name. I like all the straight lines in a row. Milbililli. This one doesn't have any chondrites in it because the stones without chondrites are called achondrites, meaning without chondrites. And they basically represent stones that were underwent like igneous processes on the parent body. The parent body is the whatever asteroid or the moon or Mars, wherever they came from. Milbililli is an achondrite, so it actually underwent melting and recrystallization. If you cut it open, you won't see those little spheres. There's another Milbililli stone. So those are some of the stony meteorites. This is a really awesome piece of stony iron from Arizona State. I tried to credit websites where I yanked these images from. This is not in my collection. That would be a nice thing to have. Arizona State has this piece from Albin, Wyoming, Again, meteorites are named after the place where they fell. So Albin, Wyoming is the name of where it fell, and then it's also the name of this meteorite. This is a slice of an iron meteorite, and you can see it's got greenish crystals in it, made of olivine, and a lot of you might know that the gem form of olivine is called peridot. So that's space peridot. It's in an iron matrix, and it's been cut and polished. That's why it's mirror shiny. And the pallasites are really only, I think, the stony irons are only 1% to 2% of falls, and there's a couple categories of stony irons. So of meteorites that are observed to fall, a very small percentage are pallasites. There's another one from Australia. It doesn't have as, I wouldn't really call that peridot. It doesn't really look very green. It's kind of brownish, reddish brown. So it's nice olivine, but it's not really peridot. There's a Imalac from Chile. You can see on the right side, it's a lot of the olivine, the stony material is weathered away, leaving sort of a shrapnel fragment of the iron. And I've got a couple of little pieces. Here's one, and the other side of the same one where all the olivine's weathered away on those. And you can see by the dime in the picture that these things are, you know, an inch around, not very big, but they're iron, and they're pretty heavy for their size, but neat looking. Here's one that's not weathered away. It's been polished on one side. This one's in my collection. It's here if you want to look at it later. This is a pallasite that isn't so spectacular from Huckata. One of the Arizona State slides from earlier was from Huckata. That's a really nice piece. I don't know why mine are so junky looking. Maybe that's why I got them so cheap. This one is the piece of Imalac that's right upstairs. I think this was donated by the Friends of the Geology Museum. This slice, I think, is about a 1/4 inch thick, and it shows real nice peridot. I have a slice in my collection that was sliced by a guy named Robert Haig, who dares to slice it thinner than anyone else dares to slice it. This is about 1.5 millimeters thick. And whenever you cut with a saw, I'm sure Alan or Nevin or Burnie could tell you that you lose a lot of material. So it's pretty risky to cut a nice meteorite like this so thin because you're going to lose a lot just to the blade. But you get really spectacular results because you can see a lot of light coming through. And now this is shot, I did this photo in the box here, so it's not actually backlit, but that piece is right here if you want to get a closer look at it. Another Arizona State slide. This is an iron from Australia. So now we're into the iron meteorites, which, as I said, were like 2/3 of the meteorites that are found that haven't been observed to fall are the irons. A lot of the Wisconsin meteorites, I was doing a little research on the 12 that have been found in Wisconsin. About half of them were plowed up by farmers in their fields, and most of those are all irons. This is a piece which is over on the table here. You can see the scale, like that. I believe I got this in a little place called Burnie's Rock Shop some years ago. It's polished, sliced and polished, and then it's acid etched. And the acid etching reveals the pattern. There's a scan of the bottom of it. You can see it's got like triangular sections. And what that is in space, iron is able to actually form crystals. As meteorites cool, they take a really long time to cool in deep space because there's not a lot of molecules out there for them to exchange energy with. So the nickel and the iron cool down from the whatever event broke them loose from the parent body that they came from. They cool slowly, and depending on the ratio of nickel to iron, I believe wider bands indicate more nickel. Is that right? I might have that backwards. I'm trying to look at my notes, but I don't know. It's one way or the other. I might have that backwards, but you'll forgive me if I just move along. That's a slice that's upstairs of the same Namibian meteorite. Really nice. I mean, this one, we don't know scale on that. It's about the size of a football. And sometime when the museum's open, maybe next month's meeting, you can check that one out in the case. Sliced, polished, and acid etched again. Now here's some from Canyon Diablo, Arizona. These are called micrometeorites. That's a little vial that's about 1 inch long, and it's over here. And you know, most of those meteorites in that little bottle are like 1 millimeter in diameter. So here's a piece from a fall in Siberia in the Sokotoline Mountains. When there's no town nearby, meteorite falls are named after the nearest geographical feature, be it a lake or a mountain range. Sokotoline felt a huge fireball storm in 1947, and the scientists were all over it, and they went out and collected it before the stuff got snowed on. It seems like it was a really large total weight, but it all broke into little pieces. And you can see on this one it's got some like thumbprinting effect, and that's a result of atmospheric melting on the way down. Now here, tektites, I consider tektites to be meteorites because they fell and they came from space and they fell, but there's a lot of questions about their origins. They're glassy meteorites basically. A lot of them, there's about 8 falls around the world of these glassy meteorites. Most of them are brown, except for the ones in Czech Republic, which are green. And the shapes on some of these Czech Republic ones, they fall in, and they're eaten away by groundwater in like sand pits, is how they get their wild shapes. And they call them hedgehogs. And I've got a lot of moldavites. I've got probably more moldavites than all the other meteorites in my collection combined because I like them. They're neat. These are some of the big ones in my collection. You can see by the dime there. The one to the left of the dime is the largest in my collection. It weighs about 56 grams, which is an uncannily large moldavite. It seems like whatever it was, it broke up in the atmosphere pretty good. Biggest one is only about 235 grams, I think. That's the big one, shot with a flash. And then today I got out my bright photo light and tried to get a picture of it from behind. And you can see some of the color coming through there. Moldavites really are best appreciated in daylight. Now this is the guy who does the thin slices, is a fellow named Robert Haig. And he's posing, I think this is Campo di Cielo, which is, I believe, an Argentinian meteorite. And he seems pretty happy to be there. This guy finds out where the falls are and goes and just grabs a wad of cash, gets on a plane, and goes there and tries to buy them off the locals. And he's had a lot of success. He was one of the first private collectors to have a big specimen of Mars rock. Now, Harvey Neininger was one of the first people to teach about meteorites. In the mid-1900s, he actually started a museum out near the edge of the Canyon Diablo crater. And he wrote a book called Find a Falling Star, which I have a copy of over here. It's a really cool book. I think it's been out of print for a while. But he's the father of modern meteoritics. He was one of the first to really popularize the study of it. Now we're getting into, this is a personal regret of mine. It's a nickel iron meteorite. Where is it from? I don't know. I wish I did. I knew where it was when I got it, and somehow I managed to separate it from its label. Maybe I thought that I'd remember. Let this be a lesson to all of us. Keep your stuff labeled, not just meteorites, but if you buy a rock or a mineral and you know where it's from, try to keep it tagged, because you might forget and you might want to know later. So here's a way to keep them tagged. This one, again, is a close-up of this. I can turn it upside down and it doesn't even lose its tag. So I put these together in like 2000 and 2001. There's the other one. And these are up for you to take a look at. And they've got descriptions, locations. I keep the total known weight, the weight of each sample. Little descriptions. Now here's a way to... This one seems like it's been preserved. Nantan was one of the earliest recorded falls, but it wasn't discovered. It fell in China in like the 1400s. And in World War II, I think it was, the Chinese government ordered their citizens to turn in their pots and pans to melt down for iron for the war effort. And in this Nantan area, they got to save their pots and pans because they found all these iron rocks. But the thing was, they wouldn't melt in the backyard furnaces. So it was finally figured out that the Nantan meteorite fall from 1492 actually did result in a lot of stones coming forth. And you can see this one, it's been polished, I think. And you can see it's got the triangular shape. Remember how the acid-etched irons have the crossing lines from the nickel and the iron crystals? It's a couple of minerals called, I think, taenite and chemisite. One is the nickel-rich version and one's the iron-rich version. And depending on the mix, they crystallize octahedrally. So what you're looking at is a cross-section of an octahedron, which is like an 8-sided polyhedron. So resources. There's some really good websites. This is the Smithsonian's page for Department of Mineral Sciences. The Smithsonian has some incredible meteorites in their collection. If you're ever in Washington, D.C., try to give an afternoon to the Rocks and Minerals building and the meteorites. They have a Tucson ring meteorite. It's an iron that's about like this with a hole in it about like that was used as an anvil by ancient people in Arizona. And the thing is, right behind it is the Hope Diamond. So I had to get out of there, but the Museum of Natural History, this American Museum in New York, has the largest meteorite in captivity is from Cape York, Greenland. I think you can see it in the middle there, but I got a better slide of it later. They've got some awesome ones in the American Museum, including the Willamette meteorite. This is a familiar page to some of you, I hope. And if not, you should check it out. The UW Geology Museum has a nice website. Lots of good information, lots of good pictures. Of course, there's nothing like going up there and checking it out, but it's a nice resource online. Arizona State, again, has a good meteoritics department, and they have a museum on their campus. Scharff, that's me. So here's some rocks from my collection. A lot of these are on the table. In fact, most of them, I think, are on the table here. This is a material called Libyan desert glass. I think it's considered to be a tektite, which is the glassy form of meteorite, but there's a lot of mystery about the origins of tektites. It's unknown whether they were ejected from the earth and like from a volcano and then fell back to earth, or whether they were a result of a cometary impact on the moon, or possibly some other celestial body breaking up. As I said earlier, most of the tektites that you find are brown. Moldavites from Czech Republic are green. These are clear, pale yellow. And the difference between tektites and impact glass is generally that impact glass has a lot of other stuff in it, and tektites seem to be pretty pure. So that's one reason that they'd be distinguished from impact glasses. Here's another couple of nickel-iron meteorites in my collection. I think the one on the left is from Canyon Diablo, and I think it's the one that was collected by Dr. Neininger. But again, I misplaced the label on it, and I wish I knew. So here's the other side of the same stones. Nickel-iron individual. I don't know where it's from. Bummer. Libyan desert glass. Here's a really strange shaped piece. There's a piece. Now, Libyan desert glass, like the ancient irons, this Libyan desert glass has been known to people for a long time, and it was used as tools. It was actually carved into scrapers and used as hand tools. So some of the Libyan desert glass pieces in my collection actually have been worked by humans, I assume in ancient times. Now here's a piece of molten glass which didn't fly through space, but you can see it's got kind of a twisted form. This is from a crater in Germany that's thought to be an impact crater where Moldavite may have originated from, but if it originated from space, then that would be wrong. But it's got roughly the same age as the Moldavites, 14.8 million years. This is a piece called Darwin glass, which is an impact glass from Tasmania. Anytime you have an impact glass, there's generally a crater associated with it, where a meteorite or a comet hit. You can see the bottom of this one has a tag on it from someone's old collection. So it'd be nice to know exactly where this one came from. Again, if I had that information, I misplaced it. I don't think I ever knew whose label that was, but that's one way of establishing provenance, which is the path of who owned art or a meteorite or anything that you might collect. It's good to know where it came from and who you got it from, and that's known as provenance. So Canyon Diablo, Arizona, Meteor Crater, Arizona. This is the largest fragment known. I guess I don't really have anything to scale. I think this one's about 4 feet long. Probably weighs several hundred pounds. There's a nice piece of meteorite from Meteor Crater upstairs. Socotoline. This one is from the Siberian explosion in 1947. This Macovich.com. This guy in New York discovered that he could sell good-looking meteorites for big money. So he's had some auctions and had some great success driving up the prices on the really high-end scale of the really good-looking meteorites. So you'll see the Macovich.com tag on some things at the end of the slideshow that are just some of the most spectacular-looking meteorites. Here's another Socotoline. This one's from my collection. It's over here. It's got the little thumb printing in it from the atmosphere. That's actually called regmaglypting, which is just a word I like to say, regmaglypting. This is the largest known meteorite. It's about 60 tons. It's in Namibia, and you can see the guy standing on it for scale. Oddly enough, this one didn't leave a crater. And I'm not sure why that is. It might have just been that it landed in the sand, and just due to terrestrial weathering, the crater just got weathered away. But it's in a park now. People have chipped away pieces of it over the years, but it's protected now. Willamette, this is another one at the American Museum of Natural History. It's about the size of a Volkswagen. This was found in Oregon. It's kind of a funny story the way it was found. A farmer apparently discovered it on land near his own, but not on his own. And he hooked up a mule team or a horse team and dragged it onto his property. And was charging people to see it when the lumber company next door realized that the large ground down trail where he obviously dragged it from led right to their property. So they wound up, I think they wound up selling it to someone who donated it to the American Museum of Natural History. So it's on display now, and it's a great looking piece. It's referred to as an oriented iron. As it fell, it stayed in one position as it was going through the atmosphere, and well, I don't know how to describe it too well, but basically, when things heat up as they're falling, the material gets pushed to the back, so they form like a nose cone shape, and so this one it's referred to as an oriented stone because it fell without turning as it fell. It just fell in one orientation, I guess is the way to put it. Cape York, 4 of the largest meteorites in the world, and one of the largest total known masses is this Cape York, Greenland. The largest one was discovered by Admiral Peary, who was, I guess, the first guy to go to the South Pole. Also went to Greenland and discovered a 34-ton meteorite and brought it back and gave it to the museum. This fellow, von Buchwald, discovered a smaller one known as the Man. There's the Man, the Woman, the Dog, and the Tent. And that's the tent, 34 tons. And Peary sold that one to the Museum of Natural History for probably, an enormous sum of, several $1,000s, which I'm sure it'd be worth a lot more than that if it could be purchased now. Also at the American Museum of Natural History, here's a piece of palisite, which is the stony iron with the peridot crystals. This is from Brenham, Kansas. Brenham is home of the largest oriented palisite ever found. It's like 1,400 pounds. And it was just discovered a few years ago by a dedicated fellow who figured that the main mass hadn't been found. These stones have been turning up for a while, but a guy actually went and figured out where he thought he might find this one, and in fact did find it. Let me see where I'm at. 8.2. Try to actually go off my notes here a little bit. Brenham. Yep. The moon. So some of these meteorites come from known parent bodies like the moon. This is not in my collection. It's Case Western Reserve University. Helps administer the Antarctic Meteorite Project. So I'm pretty sure, yeah, if you look at the naming on MIL 05035, this was found in an area of Antarctica, which I don't have them all memorized, but one of them is Allen Hills, as Allen Hills mentioned, and those are abbreviated ALH. MIL is a different area of Antarctica, and the 05 means this one was found in 2005. 035 is the 35th recorded find. Antarctica is a great place to find meteorites because when you're out on the ice, there's not much out there. And if you find a rock, it probably isn't from there. And there's also the tendency of the wind and just glacial processes push the ice sheets across Antarctica, and there are certain places where they just deposit large quantities of meteorites, and it's really been a real boon for science that that the intrepid cold-loving scientists who go down to Antarctica are interested in finding meteorites. It's like a free space mission. You don't have to bother leaving the Earth, and you get all these space rocks you can study. So that's a moon rock. Now here's a moon rock in my collection. And I've had to use circles and arrows to actually show it. For scale, this is it. It's smaller than a pencil eraser, but bigger than a pencil point. Weighs 0.005 of a gram. It's a fragment. The meteorites you might collect, you can collect whole individuals. You can collect slices, either part slices or complete slices, fragments, and micromounts. And with moon rocks, you're lucky to get a fragment or a microscopic specimen because they're very unusual and rare. And likewise, the Martian meteorites.
So how do you know it came from the moon?
Well, they've analyzed moon rocks that the astronauts brought back, and this has similar characteristics. And Mars rocks, I would imagine, it's a little tougher to figure out, but they've been able to do some analysis remotely. There've been Mars probes that did Martian soil analysis and transmitted the data back, but it hasn't been known for, I think, more than certainly within the last 20 to 40 years that some of these rocks actually came from Mars. I couldn't get this one to come out very good. This stone that fell in Egypt was reputed to have killed a dog, but it's possible that it didn't. It could just be a made-up story, but the Nakla dog is a legend that lives on. Lafayette, Indiana, I was able to get some little fragments in a gelatin capsule, and they're neat under a microscope, but not much to look at with my little the old Olympus. But there they are, and they're over here if you want to take a look at them. If you've got bionic eyes, you might see what it looks like up close. Zagami, Nigeria. This is one that Robert Haig managed to buy a large piece of off of the fellow whose land it fell on. That's a slightly better picture. Magnified. I've got it in a magnifier box. You can see the dime over on the side. It's, again, a very small piece. It's bigger than a pencil point, but not by much. Asteroids. Some of the larger asteroids have been analyzed well enough that we can tell. This particular meteorite it fell in Tataouine, Tunisia, which, if it sounds familiar to Star Wars fans, that is where they filmed Luke's boyhood home planet of Tatooine. It was filmed in Tunisia, and there was a shower of stones that basically broke up. So you don't find the Tataouine meteorite in any large size. It's pretty much all fragments, and it's thought to be from the asteroid Vesta, which is the biggest known asteroid. And this one that fell in Australia is also supposed to be from Vesta. You can see on this one, it doesn't have any of the little chondrules. Neither of these meteorites have the preplanetary spheres. So what we can infer from this is that Vesta at some point had geologic processes. It was actually active. Either the speculation about the asteroid belt is in between Mars and Jupiter, and physicists have figured that it probably used to be a planet, but it broke up. So these may have undergone geologic processes on the parent planet, or possibly Vesta was geologically active. Historic falls. This one fell in Alsace-Lorraine on the border of France and Germany. It's I don't really know how to pronounce Ensisheim, I suppose. Fell in the, I think, 14 or 1500s. Let me see if I got, yeah, November 7th, 1492. A 127 kilogram stone landed in a wheat field. And so I'd say that's probably it. That was before people believed that stones could fall from the sky, so it wasn't until much later that it was identified as a meteorite. Here's a picture of the event, drawn back in the day. Another historic fall was the Tunguska, Siberia explosion. Knocked over trees in a huge area, but no meteorites have ever been found from that, probably because the whole thing vaporized. Paragould, Arkansas is historic because it's the third largest meteorite found in the United States, and it was found by Dr. Neininger, who was specifically looking for it. He had found some smaller fragments, but he just suspected that there would be a large mass. And like the guy who recently found that Brenham, Kansas palisade, Dr. Neininger managed to find this large stone. Weighs 520 pounds? Looks like it's, from the caption here, it says weighs 520 pounds. This guy Farrington is looking at it, was the curator of geology at the Field Museum in Chicago. And he wrote a book about all the known meteorites up until, I think, 1909. And he had several hundred listed. And the total number known now is in the thousands, multi-thousands. So there's the Paragould, Arkansas stone in the University of Arkansas library. And nice to go check that out if you're in Arkansas. Meteorites that hit things are referred to as hammers. This is a stone the size of a potato. Fell in about in 1992 on October 9th. It hit a parked car, thus increasing the value of this young lady's Chevy Malibu. She sold it for about $10,000. It's changed hands since then. I think the last time it sold, it was between $30,000 and $40,000. Pretty good for an 80 Malibu, especially in this condition. But that's the inside of the stone. But the guy who owns it now takes it around to rock and gem shows and mineral shows, and he says he doesn't plan on selling it. It looks from the current pictures like it's got a new paint job, though. So Sylacauga, Alabama, November 30th, 1954, Miss Liz Hodges, the woman in the photo on the left side there, posing with the mayor and the police chief with a stone. She was sleeping on her couch, and she got hit in the abdomen. I've elected not to show the photo of her bruise. You can find it on the net. It's a bruise. It's not the greatest looking picture, but now this one fell in Claxton, Georgia, in 1984, and it struck a mailbox, which sold recently for, I think, $82,000. So, and not including the back plate, sold separately. So, you know, and I just realized, aren't mailboxes postal property? There might be some ownership issues on this one. Park Forest, Illinois. Just a few years ago, 2003, several stones struck houses and cars in a Chicago suburb. Nakla, this is the one that hit the dog, is actually a Mars rock. Well, if there was a dog. And what they've discovered recently about this one is you can see the micrographs on the right side. There's little fissures inside the stone. And coming off the fissures, I think I got a zoom in here from NASA's website. Coming off the fissures, you can see in the boxes there are smaller fissures, which are thought to have been maybe bored by bacteria. And I don't think anybody really knows for sure if it's bacterial. They're trying to figure out if it may have been bacterial or not, but it'd be interesting, you know, if it was, because it would indicate that there had previously been life on Mars. There's the dog. No, well, not the real dog, but you know. Actually, this is a logo from Knock the Dog Meteorites. It's then we've got meteorites of particular scientific interest include Murchison, a stone that fell in Australia that contains amino acids and also contains trails that look like they could be fossils. This is an electron micrograph. And you can see some things in there that look like they might be fossilized bacteria, or maybe not. I'm calling them possible fossils. I'd like to believe that there's life on Mars. That would be neat, but hasn't been proved yet. The first meteorite that they found the possible fossils on is one of these Antarctic falls. This is from Allen Hills. The location, not the gentleman, fell in 1984 and was the first one categorized that year. There's the stone itself. You can see there's a 1 centimeter cube in the side. So that's, you know, good sized Mars rock there. This one from France, I'm not going to try to mangle the name, but it's a carbonaceous chondrite, which is one of the oldest types of stones. It was the chondrites are the meteorites that have the little spheres, the chondrules. Carbonaceous chondrites are a very primitive form, so this is probably older than the Earth, and it was found to contain amino acids, including amino acids not found on Earth. Very interesting possibilities that this brings up. There's a micrograph detail, again, where, is it a fossil of something? I don't know, maybe. This one from South Africa is unique because it's got diamonds in it. There's a little test tube with some of the diamonds that they got out of it. So, and diamonds, of course, are just carbon that's been under pressure. So, interesting, you know, that peridot is not the only gemstone from space. And we get, in Wisconsin, there have been 12 meteorites known to fall. Plus, there's a really big crater out west. Let's see if I got the name of the crater offhand. Rock Elm. It was estimated that a 650 to 700 foot meteorite weighing 1,000 megatons lifted the Earth at its center more than 1,600 feet and sent shockwaves through the rocks, crushing them. Hit at 67,500 miles an hour, but nothing was found. But of the ones that were found, we've got some nice ones upstairs. And again, thanks to Rich, I've got good pictures of this one from Clark County. This is the end slice there, and then that one, this is the middle, a cross section of it. Kilburn, the one up top is actually a plaster replica, but then the two pieces down below are a part slice and an end slice. Belmont is an iron, and the piece on the left seems like it's been preserved in, what do you think that is, Rich, like acrylic?
I would guess resin.
Yeah. Some kind of plastic resin, probably to keep it from rusting. Another piece of Belmont, shown from a couple angles. Trenton. How big was Trenton? Trenton was a 33-pound iron meteorite found in 1858. Here's one of Wisconsin's early scientists. Good old Increase. Great name. Lapham might be familiar to those in the Tenney Lapham neighborhood. I assume it's named after him or his family. Looking all studious, checking out the Trenton meteorite. Then Algoma. This was another one that was plowed up in a field. Plowed up in 1887. 9-pound iron. And this is right upstairs, if you ever want to take a look at it. This one's neat. You can see this was probably oriented, where it's got, it was falling probably face first as we're looking at it, and the sides are kind of pushed back with lines in them from the way the atmosphere dug into it. There's the entire display upstairs. You can see there's a nice piece of palisade in the front. That piece there, the football-sized chunk of Gibeon, the Namibian one. And then when you're looking at this, don't forget to walk around the corner, because there's a nice chunk of Canyon Diablo that I forgot to take a picture of, but it's cool. Other Wisconsin meteorites that we don't have upstairs. Here's an old Ward's Natural Science Establishment. Was a company that Dr. Neininger wound up selling a lot of meteorites to in order to finance his his expeditions and his museum. And this is an old antique label of a piece of the Trenton meteorite from Ward's. There's an etched part slice of Trenton, the other side of it. Here's a piece of Vernon County from NY Rockman is a guy named Alan Langheinrich, I think. And then here we're into the Macovich collection. This is the website with the these are the guys that sold the mailbox for $82,000, and he's got some nice taste. He also takes really good pictures, so I figured I'd lift him and credit him. So Daryl Pitt is the name of the guy who's been doing this. There's a nice etched piece of the Australian iron called Henbury. That one, I seem to have forgotten to put a caption on there, but some kind of iron, stony iron. Gibeon, Namibia. Probably could have used white letters on that on the background. There's a nice looking piece of Gibeon. Probably a little too big to wear as a helmet, but it's a really neat shape. There's another Gibeon there. And he sells them as sculptures, and he's got, big name clients. There's a really cool partial cube of palisite from China. Neatly sculpted Libyan desert glass. And I would assume that that's probably sculpted by wind out in the desert, which would make it a ventifact, huh, Bernie?
I would say so.
Yeah. So, neat piece of Sokotoline. That was the fireball from 1947 in Siberia. Particularly good regmaglypting on this one. Another Sokotoline, and an awesome Chilean palisite from the Imelec field. Thanks, Rich. Thanks to Steve Cerio for some of those illustrations, and thank you all for coming out. Yeah, and if anybody's got questions, I'd be happy to answer them if I can. And Rich, if you want to help me turn the lights on, or maybe I can figure it out, but maybe not. Everybody can come on up and take a look once club business is all finished up. Yeah, question?
Is the moldavite, because it's a limited supply, is that something that's really going to increase in kind of rarity and value?
Probably. It seems like all the stuff that was easy to find has already been found. And some years ago, I think a lady was hurt or killed in a collapse of a roadbed over a sand pit while she was looking. And so I think they banned people in Czech Republic from looking like on public property under roadways. So it's getting harder to find. There's actually been some fake moldavite that seems to have turned up in the past few years, which is not good for moldavite collectors. And it's kind of hard to tell the difference at first glance, but I think it can be. It's got different specific gravity, so scientists are able to distinguish it from the real thing, but it's still enough to cause confusion in the market. So, in the short term, the fake is bringing the price down, but in the long term, the scarcity is bringing the price up. Nevin?
Can you address why you see so many meteorites sourced from arid places like Morocco, Tunisia?
Well,
Libya?
Kansas. Yeah. When you're looking for meteorites, if there's a lot of rocks around, it's easy to confuse your space rocks with terrestrial rocks. When you're in a place like Antarctica, there's not a lot of other things to be found. When you're out in the middle of the Libyan desert and you find a dark black rock sitting on the sand, it doesn't look like it belongs there. Likewise, Kansas, farmers who've plowed their field year after year, and then they're plowing this year and they find a rock there. I mean, what are the chances somebody from the interstate came over and threw a rock into their field? So the Plains states, the Libyan desert, Northwest Africa, Antarctica. There's a place in Saudi Arabia, I think, called Dar es Salaam. Those are nice rich places to pick. So I'd say that's probably the main reason, is just because it's different from, the stones you find are different from the surrounding rock. Bernie?
What was the size of the fall in Gibeon?
Gibeon, I think the total weight is in the thousands of tons.
But it also went for many miles, right?
You're talking about the size or the weight?
The size of the fall.
Oh, I'm not sure how big the strew field is, actually. Let me see if I can find. I had the total weight down. Total weight is estimated to be over 50 tons, which is a lot of material, but most of them aren't too big.
But I thought it was like 20 miles in length or something long.
Yeah, I didn't really have an opportunity to compare sizes on what they call the strew fields. They're generally elliptical shaped, and they represent the distribution of falls that have multiple stones. They tend to scatter in an ellipse, with most of the stones concentrated at the near side, and then depending on the angle that it hits the atmosphere, it'll be a longer or shorter. Something that comes straight in leaves an almost round pattern. Something that comes in very obliquely leaves a real elongated ellipse. So I don't know the actual size, but that's a good question.
That's interesting.
Yeah?
Is it certain that all meteorites originate from within the solar system?
It's not certain, but I'd say of the ones that have been found and identified, there's never been one identified as coming from outside the solar system. And there are an awful lot of things floating around the solar system, a lot of asteroids that can get knocked by a comet. In fact, the solar system is actually pretty big, even compared to the objects we think of, the planets and the asteroids. Comets go a long way away, and they're still pulled back by the sun's gravity. So, I mean, I guess in one sense, anything that we find here is in our solar system, so it must have gotten sucked in by the sun's gravity or solar system gravity. So, on the one hand, that's the only place that they could come from. But on the other hand, I suppose it's possible that something traveling at high speed could come through and land, but it hasn't been known to have happened yet. Be interesting if it did, though. Yeah?
Have you been
Jerry?
to Glover Bluff?
Where's that?
Glover Bluff.
No, I haven't. Where's that?
It's north of here. I can't tell you exactly where it is. Near Adden Friendship, I believe.
Yeah?
And that is an impact area, they think.
Really?
And you can see in the quarry shatter cones.
Oh, neat.
So it points to the impact.
Yeah, so all the shatter cones are basically facing away from a central point where there was a large impact.
And the quarry is all messed up. So when you look at it's supposed to be sedimentary rock, but it doesn't look like it's sitting flat at all. It's all twisted and tortured. Dr. Reed from Lawrence University, I believe, discovered it in the 50s.
Huh.
And it's just one of these weird things where you just see a piece of the evidence.
Glover Bluff, you said?
Yep. And it's a big quarry. It's got sandstone in it, and maybe prairie du chien, dolomite.
Huh.
And when I went there, they had a picture of Dr. Reed in an article, and we said, can you find the shatter cones? They said, yeah, you got to go to the south end of the quarry where they're not working anymore. And sure enough, you could see a zone that had these funny little cones.
Where the impact shattered the terrestrial rock.
Well, I think it's just the pressure,
Oh yeah.
Pressure creates these cones, and they don't create cones everywhere. It's just in this zone.
Huh.
To the rock.
A cone zone.
Yeah.
Interesting. Anyone else? Oh yeah, go ahead.
In the space program, is that of a concern of bumping into one of those things?
I suppose it is. I mean, the fact these things come in at like 60,000 miles an hour, I'd hate to be up in the space shuttle and have one of them hit the windshield. Or especially be out on a spacewalk and have it hit you in the side of the head. Yeah, Terrell?
They actually have a giant hydrogen cannon that they use to shoot microscopic pieces of metal into different things that they would construct the shuttle out of and satellites out of to see.
To test them?
Yep, just to see what would happen if these micrometeorites hit our stuff. they've been looking into that a lot because it's not uncommon for these little itty bitty tiny bits of rock and dust to be moving very fast and hit our satellites and our shuttle and different things. And so they've been doing a lot of experimentation with that because if the particle is big enough and fast enough, it can rip right through pretty much anything we can put up there. And they're doing a lot of research with that. They have just this huge hydrogen cannon, and they have a couple other magnetic guns that they use to shoot very, very small pieces of matter at things that they want to use for shielding in space.
Do you know where that's located?
I think there was one at Princeton, but I'm not sure about that. Go on the internet, you'll find it pretty quick.
Cool. Hydrogen cannon?
Yeah. Well, it uses hydrogen.
It's called light gas gun, actually.
Light gas gun?
Two-stage light gas gun.
Neat. Did I see a hand here? Yeah.
What year did the Belmont meteorite fall?
Belmont. I think its year of falling wasn't known. I think it's a find. But I have that jotted down here. Wisconsin, Belmont. Found in spring of 1958, one mass of 25.3 kilograms. So, spring of 58 it was found. I actually have a list of, I found the list of all 12. So I'll put this out, I'll put it right here. And I've got, I have a website, and if everybody wants to take one of these, you can find, I'll put all these slides on online, and I've actually been recording this. So, assuming the sounds all right, I'll put this and make it available online. Feel free to grab my web address here, and you can check all this later and show the folks who didn't show up.
Could you make it put it on the blackboard?
Yeah, sure. Make sure I'm spelling it right.
Nevin,
Lowercase.
what is that potential field trip?
Field trip, yeah.
Yeah, Ken and Megan.
Will you mention it when he's finished?
Yeah, yeah.
Okay.
They'll give us. I was forgetting that, but couldn't bring that up here.
Sorry, this is really long, but I am typing with one finger. Just remember, I am typing with one finger. I figured nobody else would have it. .com /meteorites. So when you get to I'm typing with one finger, I have a reminder to bookmark that so you don't have to type it again with one finger. But with the advent of cell phone text messaging, actually people do a lot of typing with one finger or their thumb now. So I think I got that right. I am typing with one finger. Yeah, and you got to spell it. I am typing with O-N-E finger.
Is that all uppercase?
I can type faster than I can write, especially with chalk.
Is it case sensitive?
This part is. That's a lowercase m. It's all lowercase, actually. Yeah, that part's not case sensitive, but this part is, as far as I know. Good question. Anyone else?
I'm sure Tom will entertain people to view his collection up here. And
yep, and the vocabulary sheets, feel free to grab one if you want. And the meteor wrongs. I see two, actually, it's either tektites or other things. I'd say there's 3 that are tektites and 3 that aren't tektites or meteorites at all. So see if you can tell. And I think I know the answer.
Thanks.
All right, thanks,
Yeah, one item that was overlooked during the business portion was Ken and Megan mentioned there could be a potential upcoming field trip this summer, I guess.
Yeah, it will be in the upcoming newsletter. I gave the information to Carl. What Megan and I are thinking is June 7th or June 21st, we're not sure, a Saturday, leaving from the west side of Madison and going to a cave. She wants to see a cave just south of Dubuque, Iowa. We may change the locations. We've been informed that there perhaps could be some better caves a little closer, but this is probably hour and a half, 2 hours away or something like that. Pardon me? 2.5. So we may go try to be a little closer, but plan on a field trip first part of June to a cave, and details to follow.
Right on. By the way, who wrote the newsletter with all the good stuff about meteorites in it? That was awesome. Nice work. Thanks. I liked it.
Carl's the best.
Good stuff. Yeah, Al?
I believe this weekend is at Calrain is their Gem and Mineral Show in Sussex.
Oh, okay. Yeah, is that at the Armory?
I've never been there, so I don't know.
Olympics Center.
At Olympia in Conemaugh.
Oh, okay. At the resort.
Yeah.
Okay. This weekend, Saturday, Sunday, I take it?
Yep.
Okay.
That's the Economo show?
Is it the Kettle Moraine?
Kettle Moraine Society, right? Yeah.
So don't forget, there should be some refreshments out back, silent auction, Tyrell says, and also competition for jades, opals, etc. And
Right on.
come on
Laura?
down, check out.
Yeah, what's up, Lori?
Can you tell us a little bit more about some of the formations that look like a crazy computer language almost?
Yeah, in the etched iron meteorites.
Yeah.
Yeah, they're called Widmanstätten patterns, and they're named after the director of the Vienna Imperial Porcelain Works, who discovered them. When you slice and polish an iron meteorite and etch it with acids, it reveals the boundary lines between the high nickel substance and the high iron substance. One's called kamacite and one's called taenite. And depending on how much nickel, you have wider bands. I think the more nickel is a wider band. I think, as I said earlier, I may have that backwards, but so the finer the bands are, the less nickel there is. In some of them, the bands are so wide that you'll get a meteorite that doesn't appear to have any bands, because the bands are wider than the meteorite piece itself. And then sometimes you have bands that are so small you can only see them with a microscope. And those would be the extreme high iron and high nickel versions. But you're basically looking at a cross section of octahedral crystals of iron and nickel. That I do. How's it going, Leslie? Yeah, sure. Probably their structural integrity going in at 60,000 miles an hour and hit the atmosphere like a billy club. So yeah, some of them
Oh, thanks.
well, every 26,000 years. It's supposed to happen right away, which is tomorrow. Yeah. That's how you observe the fall. The newest ones, the hybrid those ones are about 3 years old, and all the other ones are older. Cool.
I told me I brought that big slab of jade I got.
Oh, jade battle.
And I forgot that Ethiopian opal. See? Come on. You gotta let me know.
See,
these
well,
things.
you got to join the club. You get your own newsletter. Right. Okay, let that be a lesson to us all. Join the club. This has been recorded by the Soundscape Preservation Society because it sounds in a soundscape. Preserved by the Society. Copyright 2008, Soundscape Preservation Society. Recorded on the Zoom H2 handy recorder. The front and the back. That's the front left, front right, back left, back right. First surround recording by the Soundscape Preservation Society. You heard it here first. Hey, let's talk at the same time and see if we can hear anything about the difference between the front and the back. Is there good separation between the front and the back if we talk at the same time?
It's a good question.
I'd like to know.